Hi, welcome to our next set of notes talking about transformations of quadratic functions. I'm going to start with another joke that my son told me, and it was, what do cows like to sing? And it is music. Alrighty, so let's move on and talk about transformations. It is a change in the position of a figure, either up, down, left, right, or diagonal. We have something called parent functions, and I'm going to kind of jump down here to our notes. We have a parent function right here. For our quadratic functions, it is f of x is equal to x squared. So if I pull over my graphing calculator, I have x squared in my y equals. We're going to take a look at what the graph looks like. It is a parabola. This is what, again, without any transformations, what the parent function looks like. If we go to the table, okay, here's my table. I'm going to scroll up a little bit. And then we have the vertex 0, 0 and how it changes. So what I'm going to do real quick is we're going to copy this table down in our notes. And so I'm going to go ahead and put f of x and x. And what I had, it's kind of hard to do it dual, but we're only going to do 5 values, -2 to +2. And all of our transformations, we're going to compare it to this parent function with, again, its table. And so that's what that was. The very first transformation that we're going to talk about is a vertical translation. So a quick reminder that a translation, SL, this is a slide, the graph of f of x equals x squared plus k. Translate the graph vertically, okay? So if it is a positive k, that's where k is greater than 0, it's translated up. If it's a negative k, then it will get translated down. So we have 2 examples here for A and B that we'll go ahead and take a look at. And I'm going to bring back my graphing calculator. I'm going to leave the parent function up here. We'll have that there for all of them. X squared plus 4. Okay. When I graph that, my parent function, and hopefully this is our new function, up 4 units. Okay. So up 4 units. And again, it's because we have, it represents k, and it's that upward translation. So what I'm going to do now is we're going to go ahead and jump here. Let me see if this will work, if I can squeeze this in, and jump over to the table. So second table, we'll copy down the values of our new vertical translation. So again, here's the parent function under y sub 1. My new one, y sub 2, is right here. And we're going to, again, keep it with just the 5 values. So for A, it's an f of x, not y. So I have f of x, comma x. We're, again, -2 to +2. And we'll go ahead and write 8, 5, 4, 5, 8. And we're going to go ahead and graph this on our coordinate plane as well. So it's 0, 4, then 1, 5, -1, 5. And if you haven't noticed, a lot of times they do go off the coordinate plane. We just run out of room. So that is my, again, my vertical translation, how it's changed from the parent function. I'm going to quickly plot the parent function. We won't do this for every single one, but for some of them, so we can do that comparison. So here's the parent function. And I'm going to go ahead and label this as my parent function, f of x equals x squared. And then we know this is my new transformation. So let's try this again with B. For B, we see that we have a -3. And hopefully, you know, just kind of viewing the notes, we see that it will go down because my value of k is less than 0. It's a negative number. So I'm going to go ahead and switch that on my graphing calculator. Now I have -3. We take a look at that graph. There's parent function, and here it is, x squared minus 3. So I'm going to go down. Well, I'm jumping ahead just because I know the values. I do this so much. We're going to go ahead and write in the table. So we have y and x. And I'm using y because that's what I see in my equation. We're going to go again from -2 to +2, the 5 values, and at -2 it is 1. So again, we're looking at y sub 2, -2, -3, -2, and 1. And let's go ahead and finish plotting these points. So we started with 0, -3, that's the vertex. We have 1, -2, -1, -2, and then 2, 1, and -2, 1. I see right here at 3 it would be 6. So we could be a little more accurate with our points right there. And like I said, we won't do the parent function for every single one, but I see for vertical translations, here is my parent function, and again, I can compare it just across that it does go down. Now, you will find that there's a lot more translations besides up and down, okay? We have something else called a horizontal translation. Okay, horizontal, again, it's a slide. It's going to be a slide left or right because, again, it's horizontal. This time it's given to us in slightly different notation. Okay, this notation, I know you haven't learned it yet. It's going to actually be our next set of notes. It's called our vertex form. Instead of standard form, it's vertex form. And it actually connects to completing the square that we just got done doing. So if h is greater than 0, it's translated to the right. If h is less than 0, it is translated to the left. But this is the thing. So let's go ahead and take a look at this first one. If I have x plus 1 quantity squared, we actually have to solve for x for these, and we're going to use that idea of the square root method, completing the square to solve. So it's going to be set equal to 0. Not to y, because again, we're solving, so we have it set equal to 0. I'm going to find the square root. I have x is plus 1 equal to plus or minus 0. Well, there's really just 1, 0. If I keep solving for x, I have x is equal to -1. And so because x is equal to -1, I have gone, and I'm going to have you guys write this in, left 1 unit. And let's box that in. And actually, looking at my answer key, let's backtrack here. Up 4 units. I forgot to write that in. So we'll put that in for part 1 of A and part B down 3 units. So you are going to be writing in how it shifts for every graph. We did this actually with our very first functions unit, so hopefully this you remember this. So anyway, again, if h is less than 0, so we were solving for x and we find that it is -1, it went to the left. But what I want you to notice is in vertex form, it's the opposite. Okay? Let's go ahead and take a look at this on our graphing calculator. So try and do that dual. Go back to, we'll quit that, y equals, I'm going to head on down, insert parentheses, so I have x, get rid of my little squared, we'll put that at the end, and it's plus 1, parentheses, quantity squared. And I'm going to go ahead and hit graph. Parent function shifted once to the left, so take a notice of that. Let's go ahead and write down this table. And so it is f of x and x for this table. We're going to be going from -2 to +2. Just copy down the values. Notice my vertex is now 0, 1. Okay, so it's shifted over. And at -2 we're 1, at -1 we're 0, at 1 we're 4, 2 we're at 9. Okay? So we are going to go ahead and stick the parent function in here real quick. So again, just to compare, and I'm using my data from up top right up here to find that. So at 2 we're at 4, and -2 we're still at 4. And I'm going to label that again. This is f of x is equal to x squared. Put that in there. and then my new translated graph. So 0, -1, 0, -2, 1, 0, 1, 1, 4. And so I kind of have half a parabola. I'm missing at -3. If I look up here, I have -3 is 4. So I'm going to plot that, stick that in there. And I can go ahead and just, draw a little arrow that's that arrow, that's that graph. Oh, can't use words. Let's go ahead. I'm going to shift this again around. So this time, 2 ways that we can know this. We can memorize, oh, it's going to be the opposite. So if it's negative, it's going to be a +2. It's going to shift to the right 2. Or, we actually could solve this where we're going to put 0 in for y, and I have x minus 2 quantity squared. So I'm going to go ahead and do the square root method. I have 0 is equal to x minus 2. We add 2, so 2 is equal to x. So I know that this is going to shift right 2 units. And again, the only reason we have to solve this one, we didn't solve the other ones, is because of this quantity squared. Okay. Let's go ahead and make the table for this one. So I'm going to go ahead and down. And this one was -2, so I'm just going to put -2. And we'll go ahead and graph that. And there it is, shifting 2 units to the right. Let's take a look at the table. Copy down this table for us. X, Y. And because it shifted over, I actually need more values for x. So I'm going to need 3 and 4 so I can get that vertex in here. So at -1, we're 9. At 0, we're 4. 1 is 1. 2 is 0. 3 is 1. And then 4 is 4. And so I'm going to circle my vertex in this one just because it is way, way off. And let's go ahead and plot this. So 2, 0 is my vertex. I have 3, 1, 1, 1, 4, 4, and 0, 4. So again, we have a shift right 2 units from the vertex, from the parent function right here. So before we go on, let's just kind of fix a couple of typos that I noticed that I made and circle the vertex in all of our tables. So for part A, the horizontal translation, here's the vertex, and I have my f of x and x backwards. Did anyone catch that, or are you just busy copying? So, and let's come back to the top for A and B. Same thing. I have f of x and x backwards. I apologize. Just a lot on my mind today, and unfortunately, I am not the best at multitasking with a lot on my mind. So we'll go ahead and fix that. Let's circle the vertex that we have going on. We have 0, 4. 0, 0 for the parent function. Coming over here to part B, 0, -3 is the vertex, and I can't believe I made this mistake right here. So this is a newbie mistake, x, y. All right, so I apologize for all the typos. Hopefully it's all cleared up at this point. Let's go ahead and get to the rest of today's notes. So the next thing we have is something called a dilation. With a dilation, this one's just a tad challenging because the graphs of our parabolas could get wider or narrower, okay? Sometimes you will see wording called compressed. Compressed is like getting pushed together. So you're compressing something. When it's getting compressed, okay, they're talking about that vertical compression, so it will get wider, okay? For it to be narrower, okay? What you're going to do, it's going to get skinny or get stretched, okay? So we're always talking about, you know, along that y-axis. So compressed gets fatter, stretched gets skinnier or narrower, okay? So again, that's often confused, unfortunately. So we're going to be talking about the absolute value of A. So you're going to just ignore if there's any signs out front. If it is greater than 1, like this one, for instance, it will get narrower or stretched, okay? So it'll be real skinny. If it is less than 1, like a fraction, it will like move a lot slower, okay? It'll be kind of more of a smiley face, so they also call it fatter. So what we're going to do is we're going to go ahead and the same thing as the front is we will write down the table for each. So I have x, f of x, make sure I do it right this time. I'm going to go ahead and do it correctly here as well while it's on my mind. And let's plot our graphs. So dual screen with the, I'm going to just clear this one out. 1/2, I can do 1 divided by 2, okay? X squared. The other option is I could have 0.5. Take a look at the graphs. Slightly wider, okay? Now let's put our table in. So at -2, it's 2. At -1, it's 0.5, 0, 0.5, and 2. So notice everything's been multiplied by 1/2, and you know it's increasing by 1/2. And we'll go ahead and plot this. So at 1, we are at 1/2. -1, we are at 1/2. At 2, we are 2 and 2. Okay. And since I see it up here, I know that 3 is going to be 4.5. So I'll just put that in there. And so because I know it's a parabola, we'll get the opposite at -3. Taking a look at my parent function, I don't need to redo the table, but let's go ahead and plot the points so we have that comparison. So it was 1, 1, and at 2 and -2, 4. Okay. So this is key for the terminology, okay? This got fatter, it got wider, and so we'll go ahead and talk about how it is compressed by 1/2. Now let's do B. B, I have 3. Take a look at that graph, parent function, and stretched, okay? Skinnier, narrower. Let's write down this table. So going straight across, we have 12, 3, 0, 3, 12. Did I circle my vertex? There we go. Let's circle those vertexes. Let's plot our points. So I have 1, 3, -1, 3, 2, 12, way up there. That's how skinny this one is. We could barely get it on. We can't even get it on a coordinate plane. So we'll go ahead and talk about how this is stretched by 3. So everything, all of our x values multiplied by 3. Next, we'll go ahead and talk about a reflection. So for the reflection, this flips the figure over the x or y axis, okay? You have already talked about this when you talk about the difference between a minimum and a maximum, okay? So this first one, it's easy to notice that it's flipped across the x-axis. The other one where we have a negative in front of our y, or we have a f of -x, the graph is flipped across the y-axis. We don't notice it. It looks the same because a parabola is symmetric. Okay, so we don't, you know, this is just something I want you to be aware of, but we won't practice this because, again, it will look identical. On this one, part A, let's go ahead. We're going to be graphing both the parent function and the reflected function. So I'm going to go back to y equals and put that in. Oops. Let's just go ahead and put a negative in there. We'll take a look at the graphs. There it is. Okay. So the table x and f of x for this reflection notice all of your y values are now negative. We can plot that. And I'm going to go ahead and label this as f of x is equal to negative x squared. And going to the parent function, and so graphing our parent function, we'll just pull it off of our table. So we have 0, 0, 1, 1, and then 2, 4, negative 2, 4. Okay, and we'll go ahead and label this one as well as the parent function, f of x equals positive x squared. And so again, you know, this one deals a lot with, we have a minimum and a maximum depending on which parabola you're talking about. So let's talk about a study tip here at the bottom. Notice what the values in the vertex form represent. So the A opens up or down, narrow or wider, H is horizontal translation, K is the vertical translation, and our vertex will be H, comma, K, which we'll work with here in a little bit. So when we flip it over one more time, here is that vertex form that I was talking about in our study tip. Okay, so axis of symmetry, H equals x, or x equals h. And remember, we're going to be taking the opposite value that we see. The vertex will be h and k, and then the A will determine the opening. Minimum or maximum, narrow or wider. So let's go ahead and just fill in 2 of these, and then we'll do the rest in class. So you'll see what I mean. So with these translations and transformations that we're working with, we're going to look at it in vertex form and fill in what we know. So the axis of symmetry is x equals, okay, h, but we're using the opposite value, so it's negative 2. Vertex, okay, is hk, and so this is going to be negative 2, comma, negative 3, because k is negative 3. Horizontal is, we're going to go ahead and write in left 2 units, vertical down 3 units, okay, because again, k is negative 3, h is 2, but again, here's that sign, the signage to help remind us that we do the opposite. So negative times a positive is a negative, so we go left. Narrow or wider, we're going to look at A. In this case, A is 1, so we don't have anything. Okay, and then lastly, does it open up or down? It opens up, so we have a minimum. And we're going to write both in right now because your homework will either ask opening up or down, or it will ask a minimum or maximum. So we're going to just write both in. And then number 2, the last one that we'll go ahead and do together. Again, when I pull these values, I'm using vertex form, what we have right up here at the top. So axis of symmetry, it's going to be x equals h. Remember, we have a negative in front of our h, so negative times a negative, we have a positive 3. The vertex is hk, so we just talked about how h is 3. K is negative 4. Horizontal, we're going to talk about right or left. So we know it's positive 3, so it will be right 3. Vertical is a negative 4, so that's going to be down 4 units. Narrow or wider, we're going to look at A, so it's a half, so that means it's going to widen slowly, so it will be wider. And then does it open up or down? Since it's positive, it will open up, and we will have a minimum. Okay, that's it for me today.